Hello everyone, my name is JERU and I'm about to present the NI DAC card, the PCI 4461 and its variant 4462 to you guys. So these two are the variants of the National Instruments Peripheral Component Interface, the 4461 and the 4462. So before going into the details, I'd just like to brief you as to what a DAC is. DAC is the abbreviation for data acquisition, and these days scientists and engineers are doing a lot to acquire data from remote places using their protocols like PCI, PXI, IEEE, ISA standards. So there are numerous components involved while acquiring a data. The first one is the personal computer. Now, how does the personal computer play a role in data acquisition? It actually determines the speed in which the data is acquired, and recently the PCMCI protocol has made it even more flexible and convenient to get data. The limiting factor in the personal computer is, however, the hard drive, because the disk access time and the hard drive fragmentation significantly reduces the maximum rate at which data can be acquired and streamed to the disk. The software and its requirements will be detailed later. The next is the transducer. The transducer is an equipment that senses the physical phenomena and gives the corresponding electrical signals that the data acquisition card can measure. For example, the thermocouple, the thermistors and IC sensors and so on. The electrical signals are produced proportionally to the physical parameters. The next is the signal conditioning. Here, the electrical signals from the transducers are optimized by these devices. They are mainly used to amplify these low-level signals and then isolate and filter them for more accurate measurements. And the next component, which is the main component, is the data acquisition hardware. So now I'll be going into the overview of the DAC that I've proposed. The PCI 4461 has been specially designed for sound and vibration applications. It includes hardware and software needed to make precision measurements with microphones, accelerometers, and other transducers which have a very large dynamic range. It has many applications which I'll be dealing with later, and it also provides complex range of functionality for sound and vibration monitoring and analysis application. It also provides the ability to trigger by analog and digital triggering. So these are some of the features enlisted. It has a 2 simultaneously sampled analog input and 2 simultaneously updated analog output. It also has BNC connections with selectable terminations. These are used to actually interface with the oscilloscope. So this is the BNC connector. Moving on with the features, it has an 118 decibel dynamic range and a 24-bit resolution. Its maximum sampling rate is 204 kilosamples per second approximately, and it has a 92 kHz alias free bandwidth. The input range varies from 316 millivolts to a maximum of 42.4 volts. It has a 6 gain settings, AC-DC coupling, and to top it off, it also has an anti-aliasing and anti-imaging protection. Now, I said before that there are two variants in these, that's the 4461 and the 4462. So what's the actual difference between these? Predominantly most of the features resemble the same, but then the 4461 has two analog inputs and compared to the 4462 which has four, and the 4461 has two analog outputs whereas its variant the 4462 has none. 4461 has additional features like 24-bit output resolution and an update rate of 204 kilosamples per second. It also has a staggering output range of 100 millivolts to 10 volts. These three features are, however, absent in its 4462 variant. So moving on to the kernel of this presentation is the application. It's used in audio testing, automotive testing, NVH analysis, which stands for noise, vibration and harshness, machine condition monitoring, sound power, structural vibration and pass-by noise. So I'll be focusing mainly in the NVH and the MCM analysis. First is the NVH. So we all know the literal meaning of what noise, vibration and harshness is. I'll be looking at it mostly from the automotive sector. First, consider a car that's rolling out on the road, and we hear that there is noises and vibrations as a result of overheating, the noise produced by the engine, exhaust noise at the rear of the car, and the noise due to the braking mechanism involved and the wheel bearings. So in order to simulate all of them, we use softwares and interface it with computers to analyze the vibration, its intensity, and to pinpoint the accurate location. So the first model over here projects the simulation output. The red area actually denotes its high intensity of the vibration. This is the front portion of the car which houses the engine, and gradually as we move to the front cabin we can see that the color reduces, which shows that there's less vibration. This is the internal cabin of the vehicle showing no vibration, and gradually as we move to the rear part we can see that there's a slight increase in the intensity. This is due to the presence of the exhaust. This is a typical example of how NVH analysis is being carried out at Bosch Industries. Here a car is turned on and it's interfaced with the required software operating on the system using the NI PCI 4461 or the 4462. So the different simulation results will be obtained on the screen and action can be taken on later. Next is the MCM, the machine condition monitoring. This is actually monitoring the various conditions involved in a machine from an industrial point of view. Here we can see that a graph is being plotted against the machine condition and a time frame. As the conditions start to change, we gradually see vibrations, and if these vibrations go unchecked, unnoticed, they become noise, and within a short span of time, if unchecked again, it turns to heat, goes to smoke, and soon the machine involved blows up. So we can use this card in order to monitor these conditions, and we can pinpoint and we can find out the problem occurring at the vibration stage itself. So this is a typical scenario in which our card can be used, our data card can be used. Here the card is connected to a particular industrial application and monitored. The obtained information is then relayed onto the system for further action. This is a typical example of how it's been done. Now the buzzword of this generation, of this electronic generation as I would say, is the IoT, the Internet of Things. So using the smart technology, how can MCM be used? We can place the PCI 4462 connected to the device we want to monitor and connect that to an Ethernet gateway or a Wi-Fi gateway, and we can access it from a remote service, from a remote location. So many such things such as the current, temperature, vibration, noise level, flow, everything can be monitored. So these are some of the requirements and its compatibility. It runs on a Windows 2000 to Windows 7 OS. The recommended software is predominantly the LabVIEW, and the sound and vibration toolkit is what engineers look for while performing such kind of analysis. And the National Instruments DAQMX is the measurement services software that's included. I hope you guys liked the video, and I'm looking forward to your comments. Looking forward to meeting you soon. Thank you.